TensorFlow is an open-source machine learning framework, actually a full end-to-end platform developed by Google. It's one of the most popular tools in the world for building, training, and deploying machine learning, and especially deep learning models, like neural networks used in image recognition, ChatGPT-style language models, recommendation systems, self-driving car tech, medical image analysis, etc. TensorFlow is an open-source machine learning framework, end-to-end platform, primarily created by the Google Brain team. It was initially built for Google's internal research and production use in machine learning and deep neural networks. Key historical points. It evolved from Google's earlier internal system called distBelief. Google open-sourced TensorFlow in November 2015 under the Apache 2.0 license. Key figures involved include researchers like Jeff Dean, famous Google computer scientist, who helped refactor and improve it. TensorFlow powers many Google products internally, for example, search, translate, photos, YouTube recommendations, etc., and runs especially efficiently on Google's custom hardware called TPUs, Tensor Processing Units. TensorFlow is an end-to-end open-source platform created by Google. It helps developers and researchers build, train, and deploy machine learning models. And it is especially powerful and popular for deep learning, neural networks with many layers. Main uses of TensorFlow deep learning, most common and famous use: building and training complex neural networks, image classification/object detection, for example, recognizing cats versus dogs in photos, natural language processing (NLP), chatbots, translation, sentiment analysis, text generation to speech recognition, and audio processing to time series. Forecasting, stock prices, weather, sales, to generative models, GANs, for creating images, diffusion models, to reinforcement learning, training AI agents like in games or robotics. Traditional machine learning, also supported but less common than PyTorch or scikit-learn for simple tasks, to linear regression, logistic regression to decision trees, random forests via TensorFlow decision forests, to clustering, recommendation systems to large-scale linear models on huge datasets. TensorFlow doesn't have fixed rules like traditional programming, if this, then that. Instead, it learns patterns automatically by looking at lots of examples, data, and adjusting itself to get better and better. How TensorFlow actually learns from data: simple explanation. You give TensorFlow lots of examples, data equals inputs plus correct answers, called labels. Example: thousands of cat and dog photos plus labels. This is cat, this is dog. You build a model, usually a neural network. Model equals many layers of artificial neurons. Each neuron has numbers called weights. These are like tiny dials. At the beginning, arrow weights are random. Arrow model makes very bad guesses. Training process. This is where learning happens. Feed data to the model arrow. It makes a prediction. Compare prediction with real answer arrow. Calculate error/loss, how wrong it was. Use backpropagation, magic math inside TensorFlow, to find out which weights caused this error. Slightly change, update, the weights to make error smaller next time. Repeat this thousands/millions of times. Many epochs equals full passes through data. After training, arrow weights are no longer random. Arrow model learned patterns. Now it can guess correctly on new data it never saw before. Very simple picture of what happens inside input data. Photo of cat. Goes through layers, comes out as prediction. For example, 95% cat, 5% dog. Loss equals measures how far off it was. Optimizer, like Adam in TensorFlow, decides how much to adjust weights. TensorFlow does all gradient calculations automatically, very fast. First, let's break down the name TensorFlow clearly: tensor arrow. This means a multi-dimensional array, like a number, vector, matrix, or higher dimensional data. In simple terms, 0D tensor equals single number, scalar 1D tensor equals list/vector 2, D tensor equals table/matrix 3, D tensor equals stack of matrices, very common for images, height times width times color channels. Images in computer vision are represented as tensors. For example, a color photo is usually a 3D tensor, 256 by 256 by 3 for RGB. Flow arrow. This refers to how data, tensors, flows through the model. Tensorflow builds a computational graph, like a flowchart. Arrow input tensor image enters arrow passes through layers, operations like convolution, pooling, implies output tensor, prediction like this is a cat, comes out. So TensorFlow literally means the flow of tensors through mathematical operations in the neural network. Why TensorFlow is great for computer vision. Computer vision tasks involve teaching computers to see and understand images/videos. TensorFlow excels here because it has built-in support for convolutional neural networks, CNNs, the main type of model used in vision. Easy tools like Keras inside TensorFlow let you build powerful models quickly. Pre-trained models available, for example, MobileNet, EfficientNet, ResNet, via TensorFlow Hub. You can use transfer learning to get good results fast, even with small datasets. Works well on images, videos, object detection, segmentation, etc. Deployable everywhere. Phones, TensorFlow Lite, web, TensorFlow.js, servers, edge devices.
TensorFlow, often misspelled as TensorFlow, is excellent for both face recognition and object detection. These are two related but different tasks in computer vision. Object detection arrow finds and classifies multiple objects in an image/video. For example, person, car, phone, with bounding boxes. Face detection arrow, a special case of object detection that only finds faces. Face recognition arrow goes further. After detecting a face, it identifies who the person is. For example, this is Muhammad. TensorFlow remains a strong choice for self-driving car, autonomous driving projects in 2026, especially for production deployment, edge devices like in-car computers, mobile prototyping, and when you need excellent support for TensorFlow Lite, on-device inference on Raspberry Pi, Jetson, phones, or real RC cars. While PyTorch has become more popular in research and rapid prototyping for autonomous driving, many recent papers and companies like Tesla lean toward it, TensorFlow excels in scalable training and serving, TensorFlow serving, TFX pipelines, mobile/embedded deployment, TensorFlow Lite to very low latency on hardware, integration with Google ecosystem, Cloud TPUS, Vertex AI, behavioral cloning, lane detection, object detection for cars/pedestrians/traffic signs. TensorFlow is widely used for medical diagnosis tasks, especially in medical imaging, detecting diseases from X-rays, MRIs, CT scans, ultrasounds, retinal photos, blood smears, and more. In 2026, it's still one of the top choices for production-grade healthcare AI due to its strong support for deployment, TensorFlow serving, TensorFlow Lite for edge devices like phones or portable scanners, explainability tools like GradCam for highlighting disease regions, and integration with medical datasets. Common applications include detecting pneumonia, tuberculosis, COVID-19 remnants, or multiple lung conditions from chest X-rays, identifying brain tumors from MRI/CT, classifying diabetic retinopathy from eye fundus images, segmenting lesions/tumors, UNet style models, blood cell classification, for example, leukemia detection from microscopy, age/sex prediction, or anomaly detection from brain MR, is important notes for real-world use. These models are assistive tools, not replacements for doctors. They help with screening, triage, or second opinions. Always validate on diverse/local data. For example, Pakistani patients may have different disease patterns. Use metrics like sensitivity, catching true positives, crucial to avoid missing diseases, specificity, AUC/ROC, and F1 score. Accuracy alone is misleading in imbalanced medical data. For ethics/safety, follow guidelines like those from WHO or FDA for AI in healthcare. TensorFlow chatbots are used in a wide range of practical, real-world scenarios, especially where you need custom control, offline capability via TensorFlow Lite, privacy, on-device processing, low cost, or integration into mobile/embedded apps. While huge cloud-based LLMs like Gemini/ChatGPT dominate general chat in 2026, TensorFlow-powered bots excel in specific, focused, or resource-constrained use cases. TensorFlow is excellent for predicting future values in time series data, like stock market prices, for example, next day's closing price, or wheat production, crop yield forecasting, often called production in agriculture contexts. These are classic time series forecasting problems where past patterns help predict future ones. In 2026, the most common and effective approach uses LSTM, long short-term memory networks, a type of RNN in TensorFlow/Keras, because they handle sequential data well and remember long-term dependencies, for example, seasonal trends in wheat or market cycles in stocks. Key points before code. Stock prediction is very hard. Markets are noisy, influenced by news/events. Implies models often get approximately good short-term accuracy, but no one reliably beats the market long-term. Wheat/production forecasting works better with added features. Weather, rainfall, temperature, soil data. Implies multivariate time series. Start with univariate, just past prices/yields, for learning, then add features. TensorFlow brings powerful AI to mobile phones and mobile apps, but the main tool for this is TensorFlow Lite, now officially rebranded as Lite RT in 2026, though most people in code still call it TensorFlow Lite or TF Lite. TensorFlow Lite is specifically designed for on-device machine learning on smartphones, Android plus iOS, giving low latency, high privacy, data never leaves the phone, offline support, and battery-friendly performance. Popular ways to use TensorFlow Lite on mobile phones, 2026, native Android, Kotlin/Java, add dependency in build.gradle, load.tFlight model from assets. Run inference on camera frames, photos, audio, etc. Full hardware acceleration, GPU, NNAPI, Qualcomm/MediaTek, NPUs, native iOS, Swift/Objective-C, use CocoaPods or Swift Package Manager integrate with Core ML Delegate for extra speed on Apple Neural Engine cross-platform Flutter. Most popular in 2026 for fast development use. TF-Lite_Flutter or Google_ML_Kit packages. One codebase to Android plus iOS plus web great tutorials for image classification, object detection, pose estimation, React Native use, TensorFlow/TFJS-React-Native, TensorFlow.js version, or bridge to native TensorFlow Lite. Yes, TensorFlow.js is the main way to bring AI, machine learning, directly to websites, running powerful models right in the user's browser using JavaScript, with no server needed for inference in most cases. Why TensorFlow.js brings AI to websites so well. 2026 perspective. TensorFlow.js lets you run pre-trained models instantly, image classification, pose detection, object detection, text toxicity, face landmarks, etc. Do real-time inference using the user's webcam, microphone, uploaded files, or typed text. Train small models in the browser. Transfer learning fine-tuning. Work completely client-side to great privacy. Data never leaves the device. Low latency, offline support, zero backend cost for predictions. It's accelerated by WebGL, GPU and browser, WebGPU, newer and faster in modern browsers, or even WASM backends. Key advantages for websites in 2026. Privacy first AI, no sending photos/videos to a server, instant responses. No network round-trip, offline capable apps. Progressive web apps with cached models. Easy integration with React, Vue, Svelte, plain HTML/JS, etc. works on phones, tablets, TensorFlow is widely used by big companies in 2026, especially for production-grade, scalable, and deployable machine learning systems. While PyTorch has taken the lead in cutting-edge research and rapid prototyping, for example, many generative AI innovations, TensorFlow remains the go-to framework for enterprise-scale deployment, MLOps pipelines via TFX, edge/mobile inference, TensorFlow Lite, and serving at massive scale, TensorFlow Serving, Vertex AI on Google Cloud. TensorFlow powers mission-critical systems in recommendation engines, fraud detection, search ranking, image understanding, autonomous tech, and more. It's often called the COBOL of ML, mature, reliable.